The title of today's lecture is an invitation to study odds and evens. We've spent some time now on left and right, front and back, top and bottom. And this time, as well as odds and evens, we shall try something more daring. We shall try looking at before and after with a sort of time mirror. The idea of no jam today, and as it were a zero between today minus 1, which is a real number, and today plus 1, which is a real number, with a sort of nothingness in the middle, is perhaps what Lewis Carroll was aiming at. I don't know. But first, the problem of the Mobius band that I gave you last week. I said, can you make me one of these? And some of you had a try, and we've had one or two handed in. There's a nice one from Edward Tapper, which, you see, isn't a folded one. It isn't like the original unless you open it out. And he, in fact, managed to make the Mobius band look in 3D, like the 3D image that you make of that. Well, this was very clever indeed, and I know it's very difficult to do it that way. Everyone else made flat ones. Rosanna Eady made this one. She's put the folds in, and of course, when it's joined up, you can't see exactly where she split it. One or two have left them split. There's a nice coloured one here from John Mills. You see how accurately he managed to reproduce what he was set to do. Another nice one from Michael Singer, also flat one, ready folded. Another from Graham Stiff. This one he didn't join up. Now this is the sort of thing I wanted to show you, because when you unwrap it, you can see what shape of a piece Graham started with. I'll hold it against this white paper and you can see it. And you will see that he started with a piece with 2 kinks in. Now, if he'd started on a corner, he would have been able to reduce that to simply 2 straight pieces. Our youngest competitor, I think David Harris, also left one so that I could unfold it, and he did, as I'd suggested just then, and made it of 2 pieces spliced on a corner. So this shows that you are really getting the message across. I mean, it encourages me that you are understanding some of the things that I say, and I hope we're going to have some more fun today. I did, I think, ask a question earlier as to whether the universe as a whole might be left or right-handed. I think I said, is God left-handed? Well, now, very high circles in physics have been arguing about this for some time under the heading of the word parity. Now, parity is a sort of odds and evens game in itself. If parity is conserved, then the creator of the universe had no preference for the left or the right. But if parity falls, then God apparently prefers one hand or the other. And 2 people got the Nobel Prize for deciding that the universe did have a handedness. Having done so, they couldn't say whether it was left or right, so they were still left with this paradox. What is interesting is that one of the 2 people was named Yang, which is a very strange coincidence, because you remember the Chinese monad, the yin-yang, had the same name. And there are those who say that when the parity fell, it was also decided that not only was God one-handed, but he was Chinese. Now, I also suggested to you that since a mirror reversed the apparent rotation of a wheel, that it had produced the same effect as if you photographed the wheel spinning and then ran the film backwards in order to reverse the rotation. But you see, in the mirror, the wheel and its image rotated at the same time. Well, in Alice Through the Looking Glass, Alice goes to a land where time goes backwards. And the Queen says to Alice, one's memory works both ways. It's a poor sort of memory that only works backwards. Ridiculous? Not at all. The BBC, for example, know all about memory, both in its technical sense and in its human sense. Now, when we use our memories in the human sense, what we are really doing is suddenly jumping back in time and then remembering what happened from then on, but remembering it forwards. We don't really go back. We make a big jump back and then we proceed forwards for as long as we want the memory to last. Well, now, if you use tape recorders or films or computers, you record a time sequence of events and you can elect to use that memory, as it's called, in the way we do, that's by jumping back and playing forwards, or you really can play it completely back. Now, the BBC has one memory in the form of a rotating disc, and this is a very exciting piece of equipment. I thought you would like to have a look at the real thing that produces the instant action replays on a Saturday night when you watch the football match. The man scores a goal. How can they immediately put that goal on again? And then again in slow motion. There's a disc in here, a magnetic disc, spinning at 3,000 revs a minute. And we thought we'd have our own match of the day, but football would be a bit impractical in the lecture theatre. So we thought we'd have a table tennis game. And Bill put up the net. Could you clear the Mobius, Bill? And I believe there's a young fellow somewhere over here. He says he's a good exponent at this, so you come and take on the old fella, and we'll see how we get on. I think it'll probably be best if we just have a quick knock gently first, and just take it easy with me. You know, I'm not very good. Neither are you. You see? All right, that's for practice. Now they'll play it back after this time if we get a good one. Now, one more. We want to have something to really see. That's no good. Something to really see as an action replay shot. That's better. Right. Now, let's come with me and let's watch the playback. First of all, at normal speed. Now, we'd like to see... we'll do another one, I think, don't we? No. Let's have this back now in slow motion and watch the technique at the end. He serves. Return is high. Bang! Right into the net. It's the next bit I want. It's this one. It's coming up. Be patient. That's the beauty. See the expression of triumph on his face. Now we'll do it backwards in slow motion, and you'll see that this is a different game. You hit the ball, it hits the table, then it hits the other back. Oh, dear. That's good. He rolls the ball towards the net. This is fun, isn't it? It's a different sort of game. It's one that you might like to try when you get home, hitting it onto your own side first. I'm afraid the rallies wouldn't last very long. So if it's a funny place where your memory only goes backwards, then I think the Queen would say that this was memory going forwards. Doesn't seem like it, but it is. Thank you very much indeed. Now, before I put the bat and ball away, would some other volunteer like to come and just bounce the ball on the bat, just out in front here, so that we can see him, just like that, just bouncing it up and down? Any volunteer? Yes. Who are you?
John Mills.
John Mills, that was one of yours. Yeah. That's it. Just keep it going, John, a while. That's good. A bit higher. That's it. Oh, lovely stuff, yeah. Lovely, great. Yes, you're doing marvellous. All right, we'll have a look at your replay now. Just stand there, John, and watch what you did. You'll be amazed at what this man can do with his instant replay. Look at that. That's clever. Look at that. Without even touching it. I wonder what the Red Queen would have said about this. Doing the impossible. When you can do that, you can do anything. Thank you, John. Now, seeing films run in reverse like that is fun. Some are obvious, some less obvious, and some are virtually impossible to distinguish between the forward and the backward run. Now, you should have a list that you found on the seat when you came in, numbered 1 to 14, and this was just for your own benefit so that you can check yourselves. We're not going to examine you afterwards, it's just so that you can keep a record. Because I'm going to show you a lot of film clips running in reverse or forwards, and I'm not telling you which. So you have to put on your sheet, opposite each number, we run number 1, and then you put down either F or B, either forwards or backwards, whichever you think was the case. And then at the end, I'll read out the answers to you. So could we begin with the film sequence, please? Skydiving. Forwards or backwards, do you think? Just put F or B. Not as easy as it looks. All right, made up your minds? Because here comes number 2, a football game. Look at the policeman. That's a giveaway, isn't it? But isn't it fun watching this other ball game where they pass it to the opposition? That looks all right. Oh, that was clever. Yes, it's a lot of fun. That was number 2, a football game. Now, a rabbit eating and a bird pecking. Is that forwards or backwards? And another bird pecking. Make up your minds quickly now. The next one is a ship with people standing on the deck waving to you. You won't get any clues from the people waving. But those of you who are familiar with the life history of ships will probably get this one right. Interesting nonetheless. That was number 4. Number 5 will be someone walking on stairs. Number 5, walking on stairs, that's a quickie. And then, watch this one, ballroom dancing. Number 6, ballroom dancing, not so easy. Be careful of this one. Number 7, steam rising from the sea as molten lava from a volcano falls into it. So these big waves. Number 7, the sea. Number 8 will be the volcano itself in the distance there, pouring its lava into the sea. Number 8, volcano, live or not. Now be careful, because how are you going to get so close to that hot mass of lava without getting burnt? These pictures would have to be taken from a helicopter, so that could be from above or not, as the case may be. Don't be fooled by the fact that it looks as if it's going upwards. Remember how difficult it would be to photograph this. Number 8, then, the volcano and the volcanic lava. There's the volcano in the distance. There is a clue in that one. That's a long shot. The next one is a giveaway. It's a man walking. But look at the trees. Would you have been able to tell that the trees were being blown backwards? Not so easy, would it? The man walking is a giveaway. But what about this one where he's signing autographs? This is the next one, signing an autograph. Now, an audience applauding the signature. Audience applauding. Now, a very difficult quickie, a cello being played. First the bowing, then the fingering. And then the last one, James Burke talking. And there's your check answer for that one, isn't it? So James Burke talking is certainly backwards. Now then, you might like to mark your cards. You'll be astonished to know that every single one was backwards. I bet the skydivers beat you. Who got them all right? One, see me after the lecture, I could use you. Lewis Carroll's idea of talking backwards was to say that instead of saying I am going to town, was to say town to going am I. But of course that is not really talking backwards, as you know. When you record speech, you get a series of waves, vibrations. I am, I don't say these are the right waves, going to town. You've recorded. Now what Lewis Carroll thought of as talking backwards was to say we'll go back to there and play that forwards, then we'll hook back to there and play that forwards, and then hook back to there and play that forwards, and so on. And as you see, that is not talking backwards. What I am going to try and do in a minute is to go right across like that and play the whole words backwards. Could we move the board? Thank you, Bill. Now, the Queen at one stage in Alice Through the Looking Glass says, ow! And Alice says, whatever's the matter? The Queen says, I'm going to prick my finger in a minute. She's talking forwards, but pretending that time's going backwards. And it occurred to me that if you lived in that land of Lewis Carroll, it would be a polite thing to say to someone who had been unwell, to say, I hope you'll soon get worse. Think about it. It means you hope they're better now. But in the scientific world, as opposed to Alice's world, even an atom is not the same thing as its image in a mirror. Alice wondered if looking glass milk was good to drink. We could assure her that if she drank it, it would at best do her very little good. But that there is an object in the mirror that looks like ourselves is beyond doubt. But it is not you. I'm going to call it from now on your other you. If you could examine some of this creature's blood, then you'd find that the hemoglobin molecules would be left-handed, whereas yours are right-handed. Dextrorotary hemoglobin is the one that we use, not the other one. So I wonder if we really know this other person in the mirror. Can we, for example, meet them anywhere in the universe? Well, to some degree we can, even in this theatre. I want to volunteer now to come and meet his other self and try and have a conversation with him. He has to be a very special volunteer because in the first instance I hope and pray that one of you is called Stephen. Stephen, come along, just the fella. Now you've got to learn this new language, and the first thing, Stephen, is that your opposite number in the other world is going to ask you your name, and he will ask you in English. And so if he's been that polite, the least you can do is to reply in his language. So first of all, I want you to learn his language, because you're going to say your name 3 times, Stephen, 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 into that microphone. Would you do that now? Just turn to face the picture, and that's it.
Stephen, Stephen, Stephen.
I think I'd spread them out a bit more, Stephen.
Stephen, Stephen.
That's it. Now we'll play back and try and listen to what the man says. And this is a translation.
Naviet.
Naviet, have you got it? Naviet. Remember it. Have a try saying it.
Naviet.
Okay, fine. Now we'll see how he heard it.
Stephen.
Didn't he do well? It's not very difficult to learn this language. See if you can manage something more difficult now. See if you can inquire about his state of health. I'll have a go and then see if you can do as well. You want to say to him, hello, how are you? Hello, how are you? You play back from me. Who-yawa, whoella, who-yawa, whoella. Great game, this.
Hello, how are you? Hello, how are you?
All right. You like to have a try? Okay. Say it forwards first, twice.
How are you? How are you?
That'll do. That's fine. It's long enough to remember. You're just saying, how are you?
Huiawa, huiawa.
Huiawa, all right. Huiawa.
Huiaya, huiaya.
It's huiawa.
Huiawa.
That's it.
How are you?
How are you?
How are you? How are you?
Fine. Thank you very much, Stephen. Let's have a different voice. Is it a young lady? Yes. I hope your name's an easy one. Susan. Fine. Oh, this will go great. So say it 3 times, leaving space between them.
Susan, Susan, Susan.
Fine. Play it back.
Zeus, Zeus.
Zeus. Got it? Zeus. Zeus. Right. Have a go.
In Zeus, in Zeus, in Zeus.
Fine.
Susan, Susan.
Yes. Now, some words are easier to say than others. I'm going to give you an easy one, though. I want you to say the word ovary. Ovary. Say it twice.
Ovary, ovary.
Right, now if you play that back, you'll find it's an easy one.
Here, here.
Yeah.
Here, here. Ovary, ovary.
See? Thank you very much. Splendid. Consonants like M and N and R and V come through almost unchanged. You get a and a and those sounds are the same forwards and back. So you can make words up which are natural palindromes. For example, if I say to this other self, which is in that machine, suppose I say to it, okay, I want to record, sorry. If I say to it, you, how does it receive that?
We.
Right? It's an us, so to speak, you and we, isn't it? So we ought to be able to play almost anything backwards. But the hard consonants like P and D and T are very difficult, as I found when I tried to do a cup of tea.
A cup of tea. A cup of tea.
Backwards is... Stop it then.
Yes.
Okay, let me have a try now. Now, you see what happens with this one. A cup of tea. A cup of tea.
Yes. Yes.
Yip for pack up. Yip for cup up. Be awful. Listen. Dreadful thing.
Tea. A cup of tea.
Now, we decided to find out why the P was so difficult. And we realized that when you say a letter P, there is an instant when your lips are totally closed, which means you've got a few microseconds, a few milliseconds, no more, of silence, followed by an immediate start of sound. In reverse, this produces a dreadful glottal stop, a sort of yeah sort of noise, and to analyze it, we were able to slow down the speech of a cup of tea backwards without altering the pitch. Listen to this. This is what I'm trying to do. Here it comes again. Yeah. You see? They're very difficult to do, these hard consonants. Sometimes, if you choose the right words, you can simply change your accent to that of a foreigner. Let's have another go. An Englishman addressing a lady would say, "Madam, madam." And played back, the other fellow would say, "Madame, madame." French. Now, Colin Grimshaw here, who runs the TV studio in our department at Imperial College, spent 2.5 hours, is that right, Colin? 2.5 hours?
Over 2.5,
Over
yes.
2.5 hours, composing a complete sentence that he could say backwards. And he's going to play you the result.
Hello, Professor. Merry Christmas and a Happy New Year. Shall we let members of the audience have a go?
Now, I'd like Colin to say that in his real voice, for a reason I'll show you in a minute.
Hello, Professor. Merry Christmas and a Happy New Year. Shall we let members of the audience have a go?
You see, he doesn't have a Scots accent, does he? Now, listen to it again on the word let. He becomes a Glaswegian Scot. Just listen to this.
Hello, Professor. Merry Christmas and a Happy New Year. Shall we let members of the audience have a go?
Thank you, Colin. I'd love to know how he does the double P in happy. He gets it perfectly. Lots of practice. Now, many famous composers, Mozart and so on, got to writing palindromic music, which will play either way, and they tried combining normal speed and double speed and forwards and backwards until it was obvious that they were sort of hooked on this as a game. It was before bingo, after all. And here is one example of music that can be played left to right and upside down. Now, two of our audience have volunteered very bravely to come and play this duet on two instruments, a flute and a recorder. It's Rosanna and Caroline. Right, say when you're ready to go. 1, 2, 3. Thank you very much indeed. Now, the clever stuff about that is here. If I take this card and split it in half, there, this is what we had, and what we're now going to do is to turn it over like that, and you will see that the notes are identical. Thank you very much, sir. And, of course, the tune is quite acceptable. Well, now, the machine that was able to slow down that speech so that we could hear a cup of tea in slow motion without altering the pitch of the notes involves all sorts of new questions. So does anything that speeds up time or slows it down, or appears to. Now, you'll realize, of course, this has got nothing to do with mirrors. Well, one thing leads to another in science, as it does in real life. I expect you found, unless we're in danger of really getting distracted, you will find the pursuit of the interesting usually more rewarding than the pursuit of the dull. In the sheep's shop, in Alice Through the Looking Glass, Alice kept finding that the more interesting thing was always on the shelf higher than the one she was looking at. Adults, you'll often hear say, oh, the grass is greener in the next fellow's garden. It's the same sort of idea. So we'll stay a while with contracted and expanded time, and I'll now have Colin play for you a series of notes that were played in the BBC's Radiophonic Workshop, and then he's going to speed them up and see if you can predict what's going to happen as they're speeded up. It's simply a sequence of notes. We'll do the guitars after. Yeah. Thank you, Colin. That's the music, sorry. Oh, just stop a second. Okay. one thing I'd forgotten, I left out. Before they did this, they made me some music in which the notes of the instrument will appear the same forwards and back. They sound rather like bells, but it's all electronic. And they composed a piece of music which sounded attractive, played both forwards and backwards. And Colin will tell us when it changes over. First of all, there's a slow piece and then a quick piece. Okay.
We're going forwards.
Forwards.
Now reverse.
Acceptable. Same instrument, except it isn't an instrument at all in that sense.
And forwards again.
Forwards again. Would make a good opening for a film. Then a quick one. Now one with a rather livelier beat.
Starting forwards again.
Forwards.
Reverse. And forwards.
Thank you, Colin. Now from a wind instrument to a stringed instrument. I used to be an exponent of this in my younger days. I never got really beyond the hillbilly stage, you know, beyond the sort of accompanying to the sort of music you used to get in those days, the sort of... So I thought that today I would ask someone who can play the guitar to come and play a duet with me. Who's good on the guitar? Don't say we... Not with all this pop music. Someone have a go. You must have handled one. I've got a volunteer here. Right. Check the tuning first, Bill. String by string, okay? Okay. Righto, Alan. You show me what you're going to play first in the key of C, and I'll try and accompany you. Yep. You play me some chords. I think you must have been primed, you know, you wouldn't put your hands up. He's not going to make it with this. I wonder if you can see why. One is a left-handed guitar. You see, the thick string is on the inside in each case, and the thin one on the outside. So this was a guitar made for someone like Paul McCartney, in fact, who plays it this way with his right hand doing the notes and his left hand doing the strumming. So this is a left-handed guitar, but notice it is not really a different instrument. It's simply that you put the strings on in reverse order. Thank you, Bill. Now, do we as humans lose anything because we have an accepted rate of delivery of speech? I could talk much faster than do if I wanted to. And of course, if you speak onto a recorder and then speed it up, you sound like Pinky and Perky. It goes like that. But we can speed up speech without altering its pitch. This is done by taking 33 milliseconds of the actual speech and then leaving out the next 33 milliseconds, putting in the next 33 and so on, and then playing the tape at normal speed. And your ear can't detect the gaps and you get compressed speech. Now, there's a lot of thought going into this because it is considered that it is a different form of listening, and I want you to hear this compressed speech now. At first it'll seem very quick and you can't hear anything, and then slowly you'll learn to absorb the sound in a different way, and I think you'll find you can understand what the man is saying.
Look into time compressed recorded speech. When people read by listening to recorded speech, and when they want to read more than they can in the time available to them, time compression may be the solution to their problem. Research conducted at the University of Louisville, Kentucky, the American Institutes for Research in Silver Spring, Maryland, and elsewhere indicates that listeners can understand moderately compressed recorded speech without difficulty and without special training. Listeners vary considerably with respect to the fastest word rate they can understand easily. But nobody should have serious difficulty in understanding speech that has been compressed to 3/4 of its original production time. Let us suppose that a recorded listening selection was read at the average oral reading rate of 175 words per minute. Compressing it to 3/4 of the original production time would result in a word rate of 233 words per minute. That is neither a dramatic increase in word rate nor a dramatic reduction in listening time. But the ability to free 1/4 of the available reading time for additional reading may be very important for the student who, because of blindness or some other physical handicap, must read by listening. With experience, many will be able to read by listening at faster rates.
Now the real question is, how long could you take that for? Because if you could only take it for half as long as listening to me, it wouldn't be much use. But I suspect, whatever the case, at your age, you could probably last longer than I could at my age. So this is possibly one of the shape of things to come. Well, from audible things going backwards, let's take a look at visual things going backwards again. Sorry, not going backwards, being slowed down, I beg your pardon. And first of all, we're going to look at a plant that decides whether it's going to climb left-handed or right-handed. And if we speed up time, we can see this convolvulus plant climbing up a stem. Now it's feeling for something that isn't there. This one, you see, is feeling, found it, got it. Now I'm away. Now I will start to bend around like that. These things become much more alive, you know, than they are to us in everyday life. One doesn't think of a tree as conversing with another tree, but the end of that looks very like a worm or a snake looking for something to grab onto. There's nothing up there, mate. Come down. It's lower down you want to be. Come on, find it. Think of the frustration of that poor plant. He's going to go round and round until he finally hits the thing and he says, ah, there it is, and he goes round again. Then he seems to be lost again. Well, now, I wonder if you ever thought what clouds would look like if they were speeded up. You're lying on your back watching the clouds go by, but if you speed them up, you see the gathering thunderclouds there. You get the movement between clouds as opposed to the drift across your landscape. Clouds speeded up can be very interesting things. Now, from speeding up to slowing down, a hummingbird in flight is a graceful creature, especially when slowed down, as there. No man will ever make himself a pair of wings like those and support his own body whilst he has his supper. Now we're speeding it up a little, and then we shall go to the hummingbird in real time, where you won't be able to watch the individual vibrations at all. There he's taking succulent mixture from a bottle. And now a television set, not exploding, but imploding. When it's struck, it goes inwards because there's a lower pressure inside than outside. Look at the mess. Here it goes again. Strike, and some of the glass comes forwards as well as backwards, you see. Only in the slow motion camera can you see what all the bits are doing. Now, the speed of sound is another special kind of mirror. Could you have the mirror up, please, Bill? A mathematician will tell you that the ideal shape of aircraft for subsonic flight is a triangle with one side leading, flying that way. It seems all wrong today because we've got used to this streamlining of modern aircraft, but the old-fashioned aircraft, like the Spitfire of the war, conformed pretty closely to that triangle. You see, you've got the front edge leading, and then the tail fins and the wings made a neat sort of triangle, and that was the way they flew. And the first aircraft to go through the sound barrier were found to have reverse control. That is to say, when you went into supersonic flight, and if you wanted to go down into a dive, you had to pull the stick back, not push it forwards. So all the controls, left and right, up, down, were all reversed. So it really was a mirror. The mathematician then comes along and says, look, all you have to do to make the perfect aircraft for supersonic flight is to reflect the triangle in the mirror. And here's your supersonic aircraft coming with the point leading. And this is why our modern aircraft have got swept back wings, as in this film clip we've got of a Vulcan taking off. You see the almost perfect triangular shape of this very fearsome-looking aircraft. That is for supersonic flight. So the speed of sound, a mirror. Now I'm going to try one more shot, and that is of the first moonwalk of Armstrong. The poor quality of this film is because it was the very first and therefore most exciting film we saw. I remember staying up all night to see this, and when you see the man bouncing along on the moon, you are convinced that the film has been slowed down. But of course it hasn't. It's in real time. It is only apparently because of the smaller gravitational pull on the moon, the man appears to have had time slowed down. So we can only assume that when you see those lovely films of the Keystone Cops, that they were filmed on Jupiter. They must have been. Now I'm going to use the playback disc again in a moment to show you the action of an electric linear motor. Now you make a linear electric motor by taking a conventional one and, as it were, fitting a zip fastener onto it and splitting and unrolling it, which means that what in a rotary motor went round and round now travels along in a straight line. Now I know that this is only made of rubber and wood, but once we've got the idea of that, we could make one like it in steel and copper, and here is one, and we can push objects along in a straight line. Give it up. It's going the right way, I hope. Right, I'll turn up the juice first. Okay, we'll fire. We'll try that once again, and this time we'll see it played back on the machine, okay? Now we'll have our action replay, and we should see an aircraft coming into land, or roughly that. That's it. Dropped it. Now, this was only an excuse to introduce this linear motor to you, because I want to show you something more interesting than that. I'm going to put a trough on the top and prop it up so the camera can see it nicely, and I'm going to pour into the trough some iron filings. Then we're going to switch on the power and see what happens to the filings. You see, they divide up into a series of walls, as it were, walls of filings. I'll put a few more in this end. And if we look at them sideways, we shall see that there is no real regularity of structure at all. Rather, the filings are constantly forming and reforming. You see at the back there, can't make up their mind what sort of pattern to take. But these filings have helped us to make new kinds of linear motor and to understand what was really going on. Well, in those days we thought we were terribly clever to have done that, and why it should have taken us so long to take the next step, who can tell? It's always easy to do the clever thing the day after, but the day before it seems like the north face of the Eiger. If iron filings behave in an interesting manner, what would thousands of little magnets do? Do you put the board on the bill, let me see. These magnets are made of rubber with barium ferrite in, and they're like little flat sheets all magnetized through the sheet, thousands of them. We put a lid on to keep them in for a reason that'll be obvious to you in a minute. We don't take the face. You've got a switch. I'll take that off. Oh, sorry, I've got a switch. I beg your pardon. It's all right. There you see these tiny magnets all in completely random motion. They resemble the molecules of a gas. Can they really behave like molecules of a gas? And the answer is yes, because if I use this plunger, I can change the volume and I can measure the pressure by measuring the uplift on a very thin plastic lid. My temperature control is the voltage I apply. That is a lower temperature. That is a higher temperature. So I can do Charles's law. I can use different volumes by using different lids, and I can do Boyle's law. And the pressure on the lid is exactly produced in the same way as you get the real molecules of gas bouncing on the ceiling. So, this is a most useful model, because when we like, we can change it from being a gas into being a liquid, and we can understand the way in which a liquid evaporates. Although these are all magnets, and there's an electromagnet set under there, they can, by a lucky set of collisions, get enough energy to escape completely from the box. Watch this. There they go. That is the same nature as the phenomenon of evaporation in a liquid. Now, one of the most famous experiments in kinetic theory of gases was the Brownian motion, first discovered when a man looked at pollen floating about in a jar. He looked at it through a microscope and saw little bright flecks of light jumping about. And he said, those are the pollen grains having a sort of sex orgy. It's a love dance. And then other people found out that they were being buffeted by the molecules of the gas. Now, I'm going to take away the visual aid so that you won't be able to see the molecules of gas very easily. And I'll put in some smoke or pollen in the shape of balls of paper. And now the Brownian motion. The paper balls appear to be acted on by the magnetic field, but of course they're not. They're simply being buffeted by the molecules. Now we'll try and show you yet another kinetic theory phenomenon known as diffusion of gases. Now I'm going to put all the gas molecules at my end, Bill, and we'll pour this other set of smoke into the other end. That's it. And we'll see how long they take to mix. We shall need the lid on. Now you should see diffusion taking place between the two. Now the most remarkable experiment I've shown you today. All the other time reversals I've done have been by some sort of trick, and then we've played it back. I am going to show you the reverse process of diffusion as if time went backwards, but done for real. All I have to do is to turn on that switch, turn on this one, and you'll see diffusion in reverse time. Okay, so we finish up with all the paper balls at one end and all at the other. I have just done something now which is never possible in the real world. I have evacuated a vessel of all gas. You can't do this in real life, not by a long way. But in our experiment we can, and we can elect to put only pollen in, no gas, just particles of smoke. And maybe you thought they were acted on by the magnetic field. Well, here's the living proof that they're not. And I'll put in a single molecule of gas. Look what damage he can do. If you were quick enough and you could count the collisions, you could do your mean free path calculations, and the kinetic theory of gases has come to life, as it very rarely does when you do it with real gas. And there again, you think you're clever and you go home happy that you've produced a new idea for teaching methods. And another 3 months later, you say, would it have been any different if instead of using that size of piece for our magnet, we'd cut them down into very much smaller pieces? These magnets are only a cubic millimeter each, and there are tens of thousands of them. We switch on, and we get much the same. Why do it? Well, for this reason, it's when you switch off. In the ordinary way, it's not all that interesting. But if you cool it down slowly, you will see forming long-chain molecules, rather like the things you see under an electron microscope when you're looking at viruses and living tissue. You've produced a set of things that appear to belong to nature study much more than to the real world. Thank you, Bill. Now, in this group of experiments, it could be said that we've tried to see the invisible, to hear the inaudible, and to touch the untouchable. It all helps with our understanding. These are apparently impossible things to do. Alice said, one can't believe in impossible things. And the Queen said, I dare say you've never had much practice. When I was your age, I always did it for half an hour a day. Why, sometimes I believed as many as 6 impossible things before breakfast. I wonder if bouncing a table tennis ball without touching it was one of them. We've done a few impossible ones out today ourselves. Of impossible things, the great Osborne Reynolds had this to say during a lecture over 100 years ago. Here is a man ahead of his time. He's lecturing at the Society of Art, as it was then called, now called the Royal Society of Arts. But in those days, art was the word for engineering. So Osborne Reynolds, using the word art to mean engineering, said this: I have to deal with facts and only with facts, and I shall try to deal with nothing but facts. Many of the facts, or the conclusions to be immediately drawn from them, may appear to bear on the possibilities, or rather the impossibilities, of art. But in the Society of Art, I need not point out that art knows no limit. Where one way is found to be closed, it is the function of art to find another. Science teaches us the results that will follow from a known condition of things, but there is always the unknown condition, the future effect of which no science can predict. That 100 years ago was a lot of words to say. Technology, you see, advances at such a tremendous pace in almost every facet of human activity. Suppose I ask you a difficult question. What is the shortest time a man will ever run a mile? When the first sub-4 minute mile was done, people were forecasting that 3 minutes 50 would be the absolute lowest. And within a couple of years, a man had done 3:52.4 or something like that. And now they're saying 3 minutes 40. Why not 3 minutes 39? There has to be an end, and yet one cannot see one. So let's think about something a little simpler. Let's think about a world land speed record. In the old days, it was fine when you were driving your cars along with their wheels, and the wheels were on the ground for most of the time. But on the day they allowed them to put rockets on cars to do this, the thing becomes a nonsense. You can put rockets on the car and put some little wings on it and make it fly, and so long as its wheels touch the ground once in the measured mile, is that the world land speed record? Don't be silly. It's no land speed record. Likewise, a water speed record. If you take a supersonic aircraft and stick out a bit of rod at the bottom and hit the water once in the measured mile, is that the new world water speed record? I think this will probably be the last attempt ever seen on a world water speed record, and a disastrous one at that. The unfortunate Donald Campbell, in his death run for the world speed record, which in fact he was travelling, he's the fastest man ever to have travelled on water, and his hydroplane became an aeroplane in a moment, as you'll see. Up went the nose, and over he went. That, I think, is the last water speed attempt we shall ever see, because technology has made it obsolete. It's a nonsense now to say, what is a water speed record? Well, it's anything you like to think of. Altitude records are much the same. If you study the history of altitude records, they start with balloons, and then with special aircraft, jet aircraft, and then all of a sudden there's a great jump as Yuri Gagarin goes into space, and then he's the highest man, and then there's an even more enormous jump as the first men go around the back of the moon. And all of a sudden you say, altitude record? Above what? Above the surface of the Earth, or above the surface of the moon, or above the surface of Jupiter? Make your mind up. And all of a sudden there is an end to world altitude records. This is living with the times. Now try and get your minds to work on what will happen in the question of the 4-minute mile. How will this change its nature? Difficult, isn't it? Where does our technology lead us then? Away from nature or towards it? Why did nature refuse the wheel? We don't know. It must have had a very good reason, because nature usually does better than we do. My colleague at Imperial College, Gilbert Walton, has written in an article called Facts and Artifacts the following sentences. So far as is known, no living thing is made of pure metal. No doubt if we were clever enough to know, we would have rejected metals in favor of more varied organic substances. Well, we made a start. We've made plastic things instead of metal. And now we're becoming worried because that plastic container you throw on the rubbish tip is there for 1,000 years or more. And we've become worried about this. We call it a form of pollution. And already men have been trying to produce plastics which are affected by ultraviolet radiation so that they have a lifespan, like we have a lifespan, and then they degenerate into substances that can be recreated in the system. Is this then why a man was born to die, so that by the dying he could continue life itself? Are we getting nearer to the truth in this way? Well, of this I'm sure we shall try to shorten the lives not only of our plastics, but of our utensils, our homes, our machines, if only for the sake of maintaining a stable community. In utopia, you make things which are created so that they will wear out, so you have to make others, apparently. And at the same time, I am sure that we shall go on trying to lengthen our own lives. Is this the way ahead, and is this the jam tomorrow? Was there jam yesterday, as most of our parents would like to think? I refuse to believe this, because I think that today is the time, and I, of course, am essentially an optimist. I see this as a dynamic age of fantastic opportunity. I don't see scientists as evil men who make weapons of war and therefore make war itself. There was war before there was science. We make mistakes, yes, but so do all other classes of society, and we hope we learn from ours. The challenge is probably more severe than it ever was. The hazards so much the greater, but my goodness, the prizes are so much bigger. Alice went into a wood where things had no names. This wood must have been the wood of pure logic, perhaps of pure thought. Is this the jam tomorrow? Is this what we become? A man in the 11th century, over 800 years ago, wrote these fantastic words. Considering the time at which he wrote them, I think that the philosophy was very profound indeed. Ah, my beloved, fill the cup that clears today of past regret and future fears. Tomorrow, why, tomorrow I may be myself with yesterday's 7,000 years.